Now for number 5a, we have here 3 to the power of 2x plus 1, 3 to the power of 2x plus 1 plus 3 to the power of 2x divided by 3 to the power of 2x minus 1. So here we cannot add the indices. Remember, this is involving a plus sign. The first law involves multiplication, not addition. So if we have a to the power of m plus a to the power of n, we cannot use this index law. So what we can use is to factor these two terms. They have the same factor, 3 to the power of 2x, 3 to the power of 2x. Now 3 to the power of 2x plus 1 is actually the first index law. The first index law, if we read from right to left, a to the power of m plus n equals a to the power of n times a to the power of n. So let's imagine a here is 3, m here is 2x, and n here is 1. So we've got 3 to the power of 2x plus 1, which is m plus n, and that equals a to the power of m. So a here is 3 to the power of 2x, which is m, times 3 to the power of 1, and here is 1. And then we have 3 to the power of 2x all over 3 to the power of, same thing, first index law, the law that we read from right to left. So we got 3 to the power of 2x minus 1 equals 3 to the power of 2x times 3 to the power of minus 1. And so now we have the same common factor, 3 to the power of 2x here, and then we have 3 to the power of 2x here, and then we have 3 to the power of 2x here. So we can factor this 3 to the power of 2x out. So we've got here equals 3 to the power of 2x times 3 plus becomes 1, because 3 to the power of 2x times 1 is 3 to the power of 2x, all over 3 to the power of 2x times 3 to the power of minus 1. So we can cross this factor out, 3 to the power of 2x, 3 to the power of 2x, giving 1, and so we are left with 3 plus 1, which is 4, divided by 3 to the power of minus 1, and that equals 4 times 3 to the power of minus 1 is 1 over 3. 3 to the power of minus 1 equals 1 over 3 to the power of 1. Here 1 divided by 1 over 3 becomes 3. So we got minus 1 becomes plus 1. And so the final result is 4 times 3 is 12. Now for the 5b, we have here that's similar. Now we have the denominator involves addition, 9 to the power times 5 to the power of p plus 27. So basically we want to factor the common factor here. So using again the first index law from right to left, so 5 to the power of p plus 2 equals 5 to the power of p times 5 to the power of 2. 5 to the power of p times 5 to the power of 2. So we got here, we can just write down straight away the result because we don't need to rewrite again here. So 5 to the power of p times 5 to the power of 2 plus, now we have 75. 75 is 5 squared times 3. 5 squared is 25. 25 times 3 is 25. All over. So we always express in prime numbers. 5 is prime numbers. The base and 3 is a prime number. So the denominator is 9. 9 is 3 squared. 3 squared times 5 to the p plus 27. 27 is 3 times 3 times 3. 3 to the power of 3. So we can simplify. We've got 5 to the power of 2. And then we have 5 to the power of 2. So we can factor this common factor out. 5 to the power of 2 times 5 to the power of p plus 3 all over. Now we've got, what is the common factor here? We've got 3 to the power of 2. We've got 3 to the power of 3. So 3 to the power of 2 is a common factor in the denominator. So we can factor that out. 3 to the power of 2 times 5 to the power of p plus 3 to the power of 1. Because 3 to the power of 2 times 3 to the power of 1 becomes 3 to the power of 3. So we can see this becomes a new common factor, 5 to the p plus 3 in the numerator, and we put 5 to the p plus 3 in the denominator. We can cancel that out, leaving with 5 squared divided by 3 squared. So we can write it as 5 over 3 to the power of 2. So here we just use that one as if we already written the problem. So we just work that out one by one. We've got p to the power of minus 3 over 2 to the power of 2. So law number 3 involves two indices. We multiply the indices, so that equals p to the power of minus 3 over 2 times 2, so we got minus 3. And q to the power of 5, r to the power of 1 over 4. And on the denominator, p to the power of 5 times q to the power of 1 over 3 times 9, 3. Then times r to the power of minus 3 times 5 over 4 minus 15 over 4. So we have three bases here, p, q, and r. P, q, and r. So we can divide the two numbers with the same base p here, or three variables with the same base. P to the power of minus 3 divided by 3, p to the power of 5. So we have here p to the power of minus 3 minus 5 times q to the power of 5 divided by q to the power of 3. So q to the power of 5 minus 3. 5 minus 3 times r to the power of 1 over 4 minus 15 to the power of 4. So we've got 1 over 4 minus 15 to the power of 4. And that equals p to the power of minus 8 times q to the power of 2 times r to the power of minus becomes plus 1 over 4 plus 15 over 4, 16 over 4, and that equals, we turn negative index into positive, so 1 over p to the power of 8 times q squared times r to the power of 16 divided by 4 is 4. So that's the answer for question 5C. Question 5D. So the question is insert forms. We have the fifth root of a to the power of 3 times the third root of a divided by 2 times the fifth root of a to the power of minus 2. So we can work this out, still insert form, but the final result needs to be in index form, because it's asking simplify each of the question, giving answer with positive indices. So the final result needs to be in index form. Or we can convert this problem into index form and then work it out until we get the final result. So there are two ways to work that out. The first thing we want to see is that this one contains the fifth root in the numerator, and this one contains the fifth root as well, so we can simplify to make it easier. So that equals, so we have the fifth root here of a to the power of 3 divided by the fifth root of a to the power of minus 2. So we use third laws, one of the third laws, so that equals the fifth root of a to the power of 3 divided by a to the power of minus 2, and then times the third root of a, and all over 2. So we use one of the third laws here. We've got the same n root 5 here, so we just divide the argument here, a to the power of 3 divided by a to the power of minus 2, because it involves division. And so a to the power of 3 divided by a to the power of minus 2 becomes a to the power of 3 plus 2. So we've got 1 over 2 times the fifth root of a to the power of 3 plus 2 times the third root of a, and that equals 1 over 2 times fifth root of a to the power of 5 times the third root of a, which equals, so that gives 1, because that means 1 over 2 times a to the power of, now we convert this into index form, 5 over 5. So 5 over 5 is 1, 5 over 5 times a to the power of 1 over 3, a is 1, a is a to the power of 1, 1 over 3. So this one is 1, which means just simply a, for this a to the power of 5 over 5. A half times a to the power of 1 over 3. So the final result is a half times a to the power of 4 over 3. That's the first way. 5D, second way. So we convert third forms into index forms. So we write here equals a to the power of 3 over 5 times a to the power of 1 over 3 divided by 2 times a to the power of minus 2 over 5. And that equals, so we have here multiplication of two numbers with the same base. We add the indices, and then that involves division as well. Dividing two numbers with the same base, we subtract indices. So it involves multiplication and division. So we add the two indices and subtract the last index here. So that equals 1 over 2 times a to the power of 3 over 5 plus 1 over 3 minus, we've got minus 2 over 5, which equals 1 over 2 times a to the power of 3 over 5 minus minus becomes plus. So 3 over 5 plus 2 over 5 is 5 over 5. And then plus 1 over 3. And that equals 1 over 2 times a to the power of 1 plus 1 over 3. 4 over 3. So that's the second way.